Hello, I'm Andrew with S&S Diesel Motorsport, and today I'd like to talk about the effects of nozzle size on injector function and what we at S&S do to our injectors to basically optimize their performance with different size nozzles. We'll start out with one of my favorite graphs showing energizing time and rate shape. So there's your energizing time, or current trace. Energizing time is the distance there. And our rate shape will go like so. We're going to speed that guy up a little bit. There. Then, so start of energizing, start of injection. Injector is at peak needle lift there, peak nozzle flow. End of energizing, end of injection. We put a oversized nozzle on there, just bolt it on. We're going to say that this is a 100%, so double stock flow. This guy's say 1,000 cc's per minute nozzle flow. That guy will be 2,000 for the actual nozzle flow. If you just bolt it on the injector, we'll get some more numbers out here for you. At that point, our flow out of the nozzle is about 70 centimeters cubed per millisecond. So at peak needle lift, at rated pressure, 1600 bar, that is the flow rate coming out of the nozzle. On this little guy, we bolted on with just bolted on, no other changes. He's running about 125 centimeters cubed per millisecond flow rate. Now, the actual nozzle flow is double of what this nozzle is, so you should be double there. The reason being that it's not is that it is not at the proper needle lift. So let's draw another graph over here. Millimeters there, flow, and your flow versus lift comes up like so. On your stock nozzle, on your bigger nozzle, your flow versus lift comes up like so. So here, the needle lift that you desire is less than the needle lift here. So when you build your injector, you want to build it to where you are at peak flow rate. So you need to aim, you need to know what your needle lift is to get peak flow rate, but you don't necessarily want to go beyond there. You want to come up to where the curve plateaus and hit your spot right there. If you were to take your 100% nozzle like we did here, bolt it straight on the injector, your needle lift is set there. You're not utilizing the full flow potential of the nozzle because the needle's in the way. It's not lifted out of the way, you're throttling between the needle and the seat. So you need to increase your needle lift to there to actually get the full flow potential, which will put us at 140 centimeters cubed per millisecond with the extra needle lift. Along with that, it's going to extend your end of injection a little bit, which is not bad. We're ended up about where stock is when you get proper needle lift. Something else that, you're setting your needle lift, well, why not just put it out here? The reason that we don't do that is because it artificially extends your end of injection. So you're getting a lot more fuel for the same energizing time then, but you're kind of deceiving yourself because you're not getting a higher flow rate. You're essentially just extending your injection, which isn't what we want to do. Ideally, you want to have your needle lift set right where it peaks, and not go way beyond like that. So that would be kind of step one on what we do for building injectors, on getting the proper needle lift to go with the proper nozzle. So you have to be able to generate that curve to know what needle lift to set it at, and then you build your injectors accordingly. The next thing that I'd like to show is really large nozzles and when you go for body modification levels and what we do and why we do it. So, we'll go back here, get our stock nozzle back in there, and then we have a really large nozzle. First time I actually did this, I was working at Bosch Motorsport, working with Scheid. I had them EDM some nozzles for me with just a single holes, very large holes, to see how much flow we get out of an injector and at what point we weren't gaining. And what we saw is that I put this massive nozzle on and I tested it in a bench that actually didn't have rate shape, but it was opening extremely slow, and I had essentially the same quantity with this huge nozzle as I did with the stock nozzle. The reason being that the area under the curve is your quantity. So the stock injector nozzle opened up quickly, maintained, dropped quick, and so because it opened fast, you had all this area under the curve, and it was about the same with the really big nozzle because it was opening so slow. So that is when we started doing body modifications, and I guess I should back up just a little bit. The reason it opens slow is because the whole injector function is a pressure balance. It's the pressure in the top in the control volume area and the pressure in the nozzle in the sac area. And so when you lift the ball off the seat in the solenoid injector, you drop the pressure in the control volume, and the pressure in the nozzle area, the needle area, lifts the injector up, the nozzle up, needle up to open to start injecting. And you want it to open as quick as possible, but still be able to control small quantities. So as you go with a bigger nozzle, you're getting less and less pressure in that sac area to open the injector, which means it opens slower and slower. So what we had to do is actually decrease the pressure up in the top to get the injector to open quickly, and then be able to utilize the high flow rate nozzle. Because here we're not getting hardly any needle lift, and we're not even close to utilizing the flow of the nozzle. But you get it to open faster and fully, then you can utilize the actual flow of the nozzle. So with body modifications, our normal injector builds, we're trying to maintain pilot quantity, controllability. So we're basically trying to mimic the opening rate for small quantities of what a stock injector would do. On the racing applications, we'll go more aggressive because that's what people need, depending on what you're doing. I mean, we'll tailor injectors specific for your application, but a conventional build by us, we're trying to have the same controllability with small quantities as what you would have with a stock injector. The next thing I'd like to talk about would be the piezo injectors and how they respond. So that should be pretty well cover solenoids, but on the piezo injectors, fire, fire, rate shape comes up and over and down. So first time we did this, put a big nozzle on, comes up, over, and then closes really early. So stock injectors, say we had 100 millimeters cubed per stroke, big nozzle on it, we still had 100 millimeters cubed per stroke. Being that we were able to look at our rate shape, we could see exactly why. The injector was closing way early. So we were able to work inside the injectors to get them to have the same end of injection time with some internal modifications. This is the main reason that we don't just sell piezo nozzles directly. We only build piezo injectors in-house because it's not a simple bolt the nozzle on and have more fuel. It's more complicated. So even with the solenoids, we don't recommend just bolting the nozzle on. It's better for us to build them and test them in-house and build them to the proper specs. But it's not as disappointing of a result with a solenoid injector as it is with a piezo, where you're getting nearly identical quantities when you put an oversized nozzle on. So that should give you a pretty good understanding of what we do to solenoid and piezo injectors, without giving away all our secrets, to get them to function properly. And yeah, thanks for watching.